Awesome. Alrighty, I see we've got one person. I'm gonna let it go just a minute or two to see if we've got more. Sorry, somebody's trying to ask me questions right at the door. um, Alrighty. So, other people are welcome to join us as it goes in, but I think I'm just going to jump right in and we will get started on this. So, welcome to. All right, I figured it out. Awesome, great, welcome in. So, welcome to Science Explosion. My name is Zach, and uh, each week we talk about a different theme and we do different experiments. This week's theme is rocks. And right off the bat, I have to say I forgot to wear my trusty dusty lab coat last time, so got to get back into the habit of that. It's been a little bit since I've done these. Uh, so nothing says science to me quite like wearing this lab coat. But welcome everybody. We're talking about rocks, and so the uh, scientific terms for what we're going to be talking about today is going to be geology, and we're going to do a little bit of chemistry as well. So welcome in. We've got some fun experiments to try today. We're going to talk about a few different things. So welcome everybody to that. So if you want to follow along with the experiments, we're going to do two different ones today. You'll need a jar for both of them, or if you don't have a jar, any sort of bowl or glass will work fine. You'll want to get some different types of cookies that you can crumble up. If you don't have cookies, then chips, crackers, really anything that you can crumble a little bit will work. And then you'll need some vinegar for the second one. And then for the second experiment, you'll also want to uh, go outside and grab a handful of white rocks. So there is a specific reason why I'm saying that you need to get white rocks and not just any types of rocks. If you want to grab some other ones too, that'll work, but you're going to have this work a lot better if you specifically go out and grab white rocks. So that'll be for the second experiment. But let's get started on the first one. So first we're going to talk about rocks and the geology of that. I almost caught myself that time. I almost said geography. Very different thing on that. So the types of rocks is going to be one that's going to help you to understand rocks a lot better. So there are three main types of rocks. So they're igneous, sedimentary, and metamorphic. So igneous rocks are going to be the ones that come from magma or lava. And so they're going to be the ones that come from volcanoes. So if you've got a volcano and then the lava spews up from out of it, it's going to be a liquid at that point. So liquid lava or magma. So magma is when it's underground, lava is when it's overground. If you've ever heard those terms and wondered what the difference was. And then the lava or the magma is going to cool and it's going to turn into solid rock. Some of those ones are really cool looking. So granite is going to be the one you're going to see most often. So you might even have a granite kitchen top. And so that one's going to actually have come from a volcano. My favorite is obsidian. If you ever get a chance to look at that, I don't happen to have any obsidian, so I'd love to be able to show you that. Um, but that one's cool. Then there's sedimentary rock, and that one is the one that forms by, so the root word of that is sediment. So sediments are going to be little particles, and then they form on top of each other and then get pressed down. And I'm going to show you a little experiment to show you kind of how that works. And then the last one is going to be metamorphic rocks. And metamorphic rocks are going to be the rocks that are transformed older rocks. So igneous and sedimentary rocks can become metamorphic rocks. So it's usually the heat and pressure inside the earth is going to make those into things like that. So like slate, if you've ever seen that, that's a really good uh, metamorphic rock. Same thing with marble is one. So sedimentary rocks are going to be the ones that I'm going to be talking about mostly here. And there's a lot of different sedimentary rocks that you've seen. And I'm going to be talking about one at the end in particular, but some other ones that you've seen are going to be rock salt. So if you get rock salt, so salt from the ocean, that's actually going to be a sedimentary rock. It's going to be salt crystals falling to the bottom of the ocean, then getting pressed into place. And sandstone is another one. And then there's a couple more I'm going to talk about later that I think you might find interesting. So let's get started with the first experiment. That was enough talking. I just want to give you just a little bit of background information to get going with that. So I will need... I also didn't mention you'll need a fork, a spoon, a knife, something to help to scrape the things. And then you're going to need a jar. And then you are going to get those cookies or crackers, those types of things that I mentioned earlier. And so I'm going to show you a little bit of how sedimentary rocks actually form. So I'm going to start out with some old cookies. I thought this was a good use for them. Since we haven't been having after school activities, these ones have been open and sitting there for a while, so I don't know if I'd actually want to eat one of these at this point. But if you take your fork and you scrape away at this, it's going to form these crumbs. And those are the sediments. And they're going to form at the bottom of your glass or jar. So I see a question on the comments. By the way, feel free to post things in the comments. So you can see me, but I can't see you. So if you've got questions, feel free to just type them out. I'll get to them as I see them. Yeah, so for this, it doesn't necessarily have to be food. You could use things like sand, stuff like that. But food things are just easy things to find lying around. So this is the way that sediments are going to be formed. They're going to be scraped off of things. So say that this is a rock and this fork is the wind, the water, things walking over it, and it's scraping it into the jar. Now this is a very slow process, and it's happening a lot quicker here, although it's still going to take quite a while if I keep doing it like this. But this type of process happening with wind erosion and water erosion is going to take a very long time. And even me scraping it like this is to show you kind of how it works. But we're going to speed this along just a little bit, and we're actually just going to crumble the cookies with our hands, because if I scrape that with a fork for the entire time, it is going to take probably more time than I want to spend doing this whole video. So if I crumble this, try not to spill too much into here, you're starting to see a layer of sediment at the bottom. And I'm going to do a few cookies worth in here so that you can get a good picture of what this is. And I'm already making a mess, but that's okay. If you do spill this, you'll want to make sure that you sweep or vacuum. You don't want to leave these for the ants. And if you don't have ants, you don't want to get new ones. Alright, so you're starting to see that. I'm going to do one more cookie so that you have a good view of it. And we're getting a good layer. More people outside the door just waving hi to me. Okay. Whew, man, I'm getting crumbs everywhere. I'm going to probably need to vacuum up my laptop after this. Alright, so now you can see I've got a whole layer of these cookies. And I could have broken them up into little smaller pieces, so if you have a blender or a food processor, that's probably going to give you a little bit better on this, but that's okay. So, this is our first layer, And so this is one part of the sediment that comes. So let's say that this is a certain amount of time where the wind has eroded and the water is eroded and different animals are walking over it and plants are breaking it down, so it forms this sediment. So it's going to happen at different times, lengths of times, depending on where it's at. So if you are out in the middle of the desert and it is an area that's shielded from wind, this is going to take an extremely long time because there aren't a lot of things that are breaking it down. Whereas if you have a rock that's in the middle of a stream, like our Blackhawk here, then that is going to erode much quicker. And along stream beds is where deposits like this form very quickly. It doesn't take very long at all in the scheme of things. All right, so this is our first layer. And so now I'm going to get a different kind of cookie. All right, so these were little sandwich cookies, and the next ones are shortbread cookies. And the reason why I'm doing this with a different kind of cookie instead of making it all the same is to show you the difference in the layers here. Come on. All right, so then you're going to take these and also break it up into there, and you're going to notice that you're getting a strong second layer here. And it works better if they're different colors. I use black and white sandwich cookies, and then the shortbread cookies are going to look different enough that I'll be able to tell. And I think I'll do a couple different ones for there. All right, so these layers that you're making with your cookies, and again, if you don't have cookies, then you can use, I think chips would work well as long as they're different colors. You can use crackers, but you can get creative, just different things that you can crumble. All right, there. Now you can see there's the black and white layer on the bottom there, and then there's the shortbread layer there, so you can see a very clear difference between those two. So these are the geologic layers that I'm forming, and if you want to sound like you really know what you're talking about, the technical term for these is strata. So stratification is the creation of layers, but the layers themselves are called strata. So if you're talking about geology, and what I'm making right now, for anybody who's turned in after I said this before, is a sedimentary rock. So these are the sediments that are forming. All right, so let's get our third layer. I've got a few different things to make my layers with here. All righty, my fourth layer is going to be graham crackers. And they look similar to the shortbread cookies, but they should look different enough that you'll be able to tell the difference on the video. Crunch those up. And I don't have a lot of those ones. Alrighty, so you can see those, I don't know why I was going that way. So you can see all three layers I've got in there so far. You've got the sandwich cookies, the shortbread, and the graham crackers right there. All right, I've got one more layer, and that's pretzels. So I'm just gonna get a few of those and get those all crushed up here. And I'm going to make another strata, so another layer in here. Let's see. These are probably going to turn out a little chunkier than the other ones, but that's all right. It'll really help you to see the difference in the layers, though. And that is something with rock layers in general, is that some of them are going to be made out of harder layers, or harder materials than others. All right, so now we've got 4 solid layers in that. Ooh, wow, I'm making a mess this time. So we've got the sandwich cookies, the shortbread, the graham crackers, and the pretzels. So this is the layers for a sedimentary rock. So this is how sedimentary rocks get formed. They have all these different layers go on them. And over time, the new layers press down on these bottom ones. So you can see there's a lot of open space on these top ones because this top layer doesn't have anything on top of it that's compressing it down. But you can see on the bottom here that the sandwich cookies, they're a lot more compressed. They have the air kind of pressed out of them. And if you keep adding layer upon layer of this like it does outside, it's going to press them all together, and then eventually they'll get a lot more solid than they are in here, and they're going to form sedimentary rocks. They're going to get hard. They won't be able to break apart as easily. Alrighty. So that is your first experiment. That's kind of a way to see kind of the process of how sedimentary rocks get formed. All right, so I told you I'd tell you a couple more sedimentary rocks that I think are very interesting, set aside from the other ones. And some sedimentary rocks can actually be formed from living things. So I'm not talking, well, I am kind of talking about fossils, but fossils, I'll get to those in just a little bit too. But the most common types of rocks that are formed from a living thing are going to be the organic sedimentary rocks. So the ones you're going to know about for that is the coal and the limestone. So both of those are actually used to be living things. So coal and limestone used to be ancient plants and animals. Coal was ancient plants. A lot of times those were ancient forests that then had different layers put on top of them. They were compressed down and they became new rocks. And then limestone is actually ancient sea creatures. It's their shells. So if you actually get the ability to get a piece of limestone and then look at it under a microscope, you'll be able to see tiny microscopic shells in there, which I think is pretty cool. The other thing, so this isn't a rock, but this is also made from ancient plants and animals, is oil. Oil is actually formed in a very similar way to coal, and that's actually why they call oil, gas, and coal fossil fuels, because they legitimately are made from fossils, in a sense. All right, so you might be thinking to yourself, well, I know what coal looks like, and I know what gas looks like, but what about limestone? So I've got some good news for you if you want to try to find limestone, and if you do have a microscope that you can look at it, that's great. But if not, I'll be able to tell you a good way to tell for sure if what you have is limestone. So limestone actually is one of the most common rocks on Earth. It is 10% of the rocks on Earth. So if you were to pick up 10 rocks, chances are one of them is limestone. But that's why I told you to go out and get a white rock, get a pile of white rocks before this started. So that's what I've done. I've got a whole pile of white rocks here. And this is also where your vinegar is going to come in handy. So I've got a jar. It's got a little bit of vinegar in it already. And does anybody remember what we used vinegar last time for? So that was last Tuesday. We used vinegar for something else in here. Anybody want to put that in the comments if they remember? If not, that is fine. Also, if anybody has any comments, questions, feel free to put them in the comments, because otherwise it's just me speaking to you. I can't really tell what you're thinking or feeling right now. So if you've got some questions, comments, that will be great. If not, that's fine though too. So, all right. So for anybody who wasn't here last week, we used vinegar to dissolve eggshells. And eggshells are made out of something called calcium carbonate. And the neat thing about limestone is that it is also made of calcium carbonate. So we will be able to use the same process for dissolving those eggshells as we will for finding out whether something is made out of limestone or not. So if you unscrew your, well, I have a jar, so I had to unscrew the lid, but if you take your container, and then I already have some poured in here, but I'm going to dunk a couple of rocks in here. Alrighty. And if it is limestone, almost immediately they'll start bubbling. If it's not limestone, then it won't bubble. Alrighty. So I lucked out. Both of these actually are limestone because they're both bubbling right now. So it's going to be hard to see on the camera here, but if you have this at home, you'll be able to tell it a lot clearer. Okay, there we go. So now the water is starting to get a little bit cloudy because there's enough bubbles on here. So what's happening right now, if you missed the one last week, is that the vinegar is dissolving the calcium carbonate that is the limestone. And so that is a chemical reaction that's happening right now. And this time I actually have exactly what chemical reaction it is. So just in case anybody's interested in the chemistry behind this, it is going to be the limestone plus the vinegar is going to combine. So if you remember from last time, those bubbles in there, that is carbon dioxide, so CO2 that's being released out of there. And so that is the same thing that plants take in to breathe. So remember that animals breathe out oxygen, or sorry, excuse me, the other way. Animals breathe in oxygen and then out carbon dioxide, and plants breathe in carbon dioxide and out oxygen. So what is going right in there right now is carbon dioxide. Also, that's the stuff, if you have soda or anything carbonated, that is carbon dioxide that is dissolved into there. So I would not recommend drinking this water because I did just put some dirty rocks in it, and also it's not water, it's vinegar. But if you were to take a sip, which remember don't, it would be carbonated at this point. It would taste fizzy. It would also be gross because it's just mainly pure vinegar at this point. But the interesting thing about this is that it's carbon dioxide, but you're also going to get a couple other things out of this. So if you leave this in here and let the rock dissolve as much as it can, the rock is going to turn from calcium carbonate, so calcium and carbon, to calcium acetate. And the vinegar is going to turn into water. So at that point, it is going to be a slightly carbonated water. All right, and I would definitely recommend, if you're following along with this, I would leave this long enough for the rock to dissolve and for at least one of them so that you can see what this looks like. And if you let the rock dissolve and then let the water evaporate, what you're going to be left with is a very powdery feeling rock, but on top of that rock, you're going to get crystals that will grow off of it. And those are calcium acetate crystals. So this is another one that's going to take quite a while, but eventually this rock will dissolve until you see the bubbles stop going from the rock. It's still dissolving it. Alrighty, so now if you remember what I said that limestone is made out of, it is, oh, and also if you want to grab just random rocks and put them in the vinegar, you'll see that they don't bubble. And you can try this out. So it's pretty consistent that it's limestone that will dissolve and most other types of rocks will not. Now I will give you a little bit of a warning here because if you've got a fossil in your limestone, it depends what kind of rock that is. You might end up actually exposing it and then cleaning it off with that, but it might also be a fossil that's made of calcium in that, and that's actually going to dissolve your fossil as well. So be careful if you have a fossil not to put them into vinegar unless you're being very careful with why you're doing that. All right, but remember that limestone is made up of teeny tiny little seashells. So these are shells of very small ocean creatures. So most of them you wouldn't even be able to see without a microscope. Some of them are also chips from larger creatures' shells. And so think about the fact that right now I'm putting this in an acidic solution and it is dissolving it. So if you hear people talking on the news about what is happening with ocean acidification, this is actually a very similar thing. So as ocean temperatures absorb, ironically enough, this is releasing CO2, but as water absorbs carbon dioxide, it actually gets slightly more acidic. And if that happens enough, like is happening right now, it makes the water too acidic for things with shells to form. So right now you can actually see that there's a lot fewer things with shells that are living right now because the water is too acidic for them to be able to build their shells. Now, that's very similar. It's not exactly what's happening with this, but it's a very similar type of process. So the same way that this rock made out of ancient shells is being dissolved in the vinegar, so the same thing is happening with things that live in shells right now. So clams, snails, all sorts of different, the types of seashells that you find on a beach. Those are also made out of calcium carbonate. And those right now are being either dissolved in the water, or the ones that are being born now are having too hard of a time to be able to make them. So it's still happening. It's not that the water is acidic, but it's more acidic than it was. So I think that's just, if you ever hear people talking about that, this is a good way to be able to understand what that is. So that actually is going to release, so this is releasing CO2, which, okay, now you can really see that the water is getting very, very bubbly in there. And that's probably because I have a couple different rocks. And the more jagged the rock that you have, the faster that it's going to dissolve, because it's going to have a higher surface area than if you have a smooth rock. So if you really want to speed this up, you could also chip it into smaller pieces, and then it would go really fast. But I think it's really fun to watch the bubbles slowly come off of there. But anyway, so when the CO2 ends up in the water, it creates something called carbonic acid. So water is made up of something called, so water is H2O, so two hydrogens and an oxygen, but CO2 will combine with that and create carbonic acid, and that is H2CO3, if you want to know the chemistry behind it. And so that means it's more acidic, and then it's going to make it harder for the shells to form, also for coral to form. If you ever hear people talking about bleached coral, that's very much a similar thing on this. So if you want to know more about that, there's lots more that you can look into that as well. All right, so I also want to show a couple books. If you're interested in learning more about geology and about rocks, we have a really cool section on that in the library. So I'm going to show you just a few of them real quick here. Oh, wow. Let's see if it'll let me grab it. All right, great. So let's see here. So if you're wanting to know specifically the types of rocks that are in Iowa, so assuming that most of the people watching this are in Iowa right now, then this one is good. So this is the Minerals of Iowa. It's a guide for the different types of things that you're going to find around here. If you want to know where you're looking for, there are some neat maps in here. So if you're wanting to look for cool rocks or fossils, this is a really good one to start with. Also, Rocks and Minerals, a guide. This one is going to give you a lot more basic information, some really cool gemstones if you're interested in learning about those, how to tell different types of rocks, all that sort of thing. All right, and then we've got a couple books that are about the elements. I think those are really cool to check out as well if you're wanting to know a little bit more about the chemistry behind that. And then this one's going to be for a little bit older audience, but I think it's a cool one. So this one's called Reading the Rocks, and it's kind of a history of geology and paleontology. Uh, Something else that is neat is actually just a couple hours ago, somebody donated a fossil collection to the library. And this is a kit with a few different fossils in it. And there's a lot of really neat ones in here. So we've got an ancient shark tooth. We've got this one is made up of a bunch of teeny tiny little worms. This one is a trilobite or a trilobite. I'm probably pronouncing that wrong. Let's see if you can see it a little bit on there. So this is sort of like this is an ancient crustacean. So this is sort of like an ancient sea bug that used to be really common, but not anymore. So if you want to see that, we've got that at the library. I'd love to show that off to people as well. Alrighty, and I have one more easy science experiment. If you are interested in learning about rocks, one of the ways that rocks get classified is their hardness scale. And so that is literally just how hard the rock is. And today you can buy picks that will tell you exactly how hard a rock is based on the way that you scrape it. And you're welcome to buy those if you're interested. But the way they originally figured this out was that they literally took two different kinds of rocks that they knew what they were, and they scratched them against each other, and they put them on a scale saying this rock could scratch this rock, but it couldn't get scratched by this rock. And then they just made a scale going up of how hard or how soft the rock is. So does anybody know what the hardest rock is? This one, I can't remember what the softest one is off the top of my head. There's some very soft rocks like sandstone you'd be able to scrape very easily, or coal maybe. But the hardest rock on this scale, the one that can scratch any other rock but won't be able to be scratched itself, is diamond. And so I've got diamonds on my ring right here. And so if I wanted to, I wouldn't because it would damage the rest of my ring, but I could scratch any one of these rocks with the diamond on my ring without it getting scratched itself. And that's actually why if you've got a drill or a screwdriver, sometimes they'll put teeny tiny little diamonds on the end of that. So that's a diamond tipped tool. And they do that because it's a lot harder than just the other types of metal that it's made out of. So that's one that I think is fun if you want to look that up on your own. But otherwise, those are my experiments for the day. That is my talk. So does anybody have any questions for me? Does anybody have anything they wanted to ask? Any clarifications on, ooh, this is really bubbling now. You can barely see the rocks through the water now. It's clouded up so much. Also, the random particles that are floating in the water there, that is going to be any impurities in there. That will be anything that was on this rock or in it that isn't limestone. So a lot of times there'll just be some other types of rocks. It also could be that I didn't wash the rocks before I put them in, and so it could just be grime that was sticking to them. But anyway, if anybody has any questions, feel free to type that into the comments. If you have questions on the experiments we did today, any of the things we talked about, or if you have any science questions in general, I will do my best to answer any questions that you've got on a variety of science topics, or you can try to stump me, anything like that. I will give just a minute here to let people type in any questions they've got. And if nobody has any questions, that is fine, but just always remember, questions are a way that we learn about things, so there is no such thing as a bad question. I think you can learn from any sort of question. So anyone have anything else they want to ask me? And if you think of things later, then feel free to go back into this and type it into the comments. I'll look at these at another time as well. All right. By the way, if you made this out of cookies, you could feel free to, assuming that you crumbled it up with clean hands, then you could probably put something like pudding or whipped cream or ice cream into this. It would fill in the cracks there, and that'd probably make a fairly tasty dessert. I did wash my hands before this, but I don't know if I really want to eat these because some of those cookies were very old. Alrighty. So if nobody has any questions for me, then I will just say thank you so much for joining me. So again, my name is Zach. This is coming out from Hudson Public Library. We do a science explosion every week from at Tuesday from 3:45 to 4:45. I think we finished just a little bit early today, but that's okay. Sometimes we'll go just a little bit early. Sometimes it'll go just a little bit long. But join us next week. We're going to be having another one of these, and it is going to be a lot of fun. So thank you everyone so much for joining me, and I will see you next time. Bye.